We soar through the endless night of space, the inky blackness stretching infinitely in every direction. Stars glitter like shards of glass, their light traveling across unfathomable distances, each one a silent witness to the eons that have passed. Nebulae swirl in vibrant colors, clouds of gas and dust forming cosmic tapestries that defy imagination. We feel a pull, a magnetic curiosity, urging us forward, toward the unknown. What if we could move faster than anything we have ever conceived? What if the universe itself could be traversed at the speed of light? The human mind has always been captivated by speed. From the first will carved from stone to the thundering locomotives that transformed continents, to jets that pierced the clouds and rockets that breached the atmosphere, we have chased velocity as if it held the key to freedom itself. We dream of leaving Earth behind, of racing across the galaxy, of touching the stars and seeing the universe unfold before us at a glance. That dream, as intoxicating as it is, collides with an invisible wall, a fundamental law written into the fabric of reality. As we imagine this journey, we encounter the paradox of desire and limitation. Our aspirations are boundless, yet the universe has rules that do not bend for human ambition. Each attempt to surpass these boundaries reveals the harsh truth. There are ceilings we cannot shatter, speeds we cannot attain, limits we must accept. Yet the allure of the impossible persists, a flame flickering against the void, urging us to explore, to question, to seek. In the silence of space, we confront both awe and fear. The cosmos is breathtakingly beautiful, yet it is indifferent, vast, and unyielding. A photon, traveling across light years, seems almost taunting in its ceaseless motion, a reminder of the ultimate speed limit we cannot breach. We are tiny, fleeting, yet undeniably curious, propelled by an insatiable need to understand the rules of the universe. This is the beginning of a journey not just across space, but into the very laws that govern it. We will explore what it means to dream of light-speed travel, and why that dream, as exhilarating as it is, remains tantalizingly out of reach. Through the lens of human ambition and cosmic law, we confront the ultimate question. Can we ever truly outrun the light, or is this pursuit destined to remain a magnificent, unreachable horizon? We see spacecrafts imagined in dazzling detail, slicing through starscapes, engines blazing with impossible energy, humanity's dreams rendered in brilliant motion. Yet for every step forward, the laws of physics loom larger, relentless and absolute. The closer we imagine getting, the more the universe reminds us of its boundaries. Each attempt, each fantasy, emphasizes both our ingenuity and our limitations. The journey begins not with propulsion, but with wonder. We gaze at the heavens and feel both the exhilaration of possibility and the weight of inevitability. The vast distances, the shimmering galaxies, the relentless march of time. All these elements create a tension that defines the story, the eternal struggle between ambition and the immutable cosmos. As the scene expands, we witness human figures staring at the night sky, small against the grandeur of stars, eyes reflecting light that has traveled millions of years. The contrast is profound. The fragile, fleeting lives of humans against the ageless, immovable universe. It is a cinematic reminder that every dream of speed is not just a technical challenge, but a philosophical one. What does it mean to chase the impossible? And what does it reveal about our nature, our curiosity, and our relentless desire to transcend ourselves? With each moment, the tension grows. The audience is drawn into the wonder of the cosmos, while simultaneously sensing the impossibility that awaits. Light itself becomes both a guide and a barrier, a shimmering thread that connects everything, yet also defines the limits beyond which we cannot go. In this juxtaposition of beauty and impossibility, the stage is set for an exploration of physics, ambition, and the human spirit. We leave viewers on the edge of awe and curiosity, the opening hook secured. The dream of moving at light speed is more than a technical challenge. It is the ultimate confrontation with the universe itself, a journey that will test every understanding, belief, and hope we carry about what it means to explore. The voyage begins not with motion, but with imagination, and with the undeniable, breathtaking question. Can we ever truly reach the speed of light? Humanity's fascination with speed is as old as civilization itself. From the first crude wheels rolling across dirt paths to the thundering hooves of horses that carried messengers and warriors, the desire to move faster has been intertwined with survival, exploration, and ambition. Every technological leap, from the invention of the chariot to the steam engine, was fueled by a combination of necessity and curiosity. There is an almost primal thrill in acceleration, in feeling the wind or energy pushing forward, as if speed itself unlocks some hidden truth about freedom and power. As centuries passed, humans looked skyward, imagining ways to escape the bonds of Earth. Balloons lifted explorers into the clouds, and early flight pioneers defied gravity with fragile contraptions of wood and canvas. The roar of engines and the daring feats of test pilots captivated imaginations, making speed a symbol not only of progress but of human daring itself. Cinematic visions of these early flights, with clouds rushing past and engines trembling under strain, evoke both awe and a subtle fear, reminding us that pushing limits has always carried risk. The industrial age accelerated this obsession. Trains crisscrossed continents, connecting cities and nations in ways that once seemed impossible. Automobiles roared onto roads, racing toward a future that seemed to stretch endlessly ahead. Each advance in speed was accompanied by stories of triumph and disaster, innovation and failure, weaving a narrative of human persistence against nature's constraints. We are drawn to these stories because they reflect an eternal human desire to transcend our physical limitations, to shorten the vastness of time and space, and to experience the thrill of moving faster than the ordinary. When humans first glimpsed the possibility of space travel, speed became not just a symbol of ambition but a necessity. Rockets designed to escape Earth's gravity represented the ultimate challenge, overcoming the pull of a planet to reach the infinite void beyond. We imagine the raw power required, the fire and smoke and thunder of liftoff, and the surreal silence of orbit where speed is no longer about resistance but about mastery of momentum. This contrast, between the violent struggle to leave the planet and the serene drift among the stars, creates a cinematic tension, blending excitement with reverence for the cosmos. Yet even as technology advanced, the dream of reaching the stars exposed an invisible ceiling. No matter how powerful our engines, the speed of light remains untouchable, a cosmic barrier that defines the ultimate boundary of motion. Humans confront a paradox. The more we strive to move faster, the more apparent the laws of physics become, unyielding and absolute. This tension between aspiration and limitation drives both fascination and frustration. It is the very essence of what makes speed so compelling. It promises freedom, yet reminds us of our finite place in the universe. Throughout history, stories of speed have carried both hope and caution. Tales of explorers, aviators, and astronauts evoke wonder and inspire future generations. Yet they also hint at the dangers that come with defying nature. Accidents, crashes, and near misses serve as grim reminders that the pursuit of velocity is never without consequence. Cinematic storytelling amplifies this duality. Sweeping aerial shots of racing cars or spacecraft convey exhilaration, while moments of failure underscore the stakes. We are drawn to speed because it mirrors life itself, a delicate balance between risk and reward, courage and consequence. This human obsession is not limited to machines. Even in art, literature, and imagination, speed has been a recurring theme. From the arrows of mythic heroes to the futuristic starships of science fiction, our collective psyche equates velocity with transcendence. It is in this imaginative space that we first entertain the notion of moving at the speed of light, a concept simultaneously exhilarating and terrifying. The mind races ahead, envisioning possibilities that defy reality, creating a tension between what we desire and what we know is physically achievable. As we journey from Earth's surface toward the stars, the narrative of speed transforms. It is no longer simply about thrill or competition. It becomes a lens through which to examine human ambition, ingenuity, and limitations. The contrast between our dreams and the universe's immutable laws evokes both awe and humility. Each incremental advance in speed, each breakthrough in technology, brings us closer to the ultimate question. Can we ever truly reach the velocity that defines the cosmos itself? By tracing the arc of human history, from stone wheels to rockets, we see that the pursuit of speed is a defining feature of our species. It is a story of curiosity and daring, of imagination and ingenuity, set against a backdrop of unyielding natural law. And as we stand on the brink of interstellar aspirations, this obsession with speed sets the stage for a confrontation with the ultimate barrier, the speed of light, a limit that has captivated and confounded thinkers, dreamers, and scientists for generations. Light is the universe's most fundamental messenger, traveling across unimaginable distances to carry the story of existence itself. It is both wave and particle, dual in nature, dancing through the cosmos with a precision that defies comprehension. Every photon that reaches our eyes has traversed vast expanses of space and time, connecting us to stars that may have burned out millions of years ago. This ethereal journey creates a cinematic tapestry. The glow of distant galaxies, the shimmer of nebulae, and the subtle illumination of planets orbiting unseen suns. Light shapes the universe we perceive, revealing its structure while simultaneously imposing the ultimate limit on motion. The behavior of light is extraordinary. Unlike any other object, it has no mass and yet carries energy, traveling at a speed so immense that it seems instantaneous to the human mind. But even this speed, 300,000 kilometers per second, is a ceiling, a cosmic speed limit embedded in the very fabric of reality. Through cinematic visuals, we imagine photons racing past spacecraft, slipping effortlessly through obstacles, and marking the passage of time itself. Their motion is a paradox. Constant, relentless, untouchable. To chase them is to confront the ultimate constraint of nature. Light is also a time machine. The photons we see from distant stars left their source millions or even billions of years ago. Each beam is a snapshot of history, a frozen moment traveling through the void. We perceive constellations not as they are, but as they once were, reminding us that our understanding of the universe is always mediated by the finite speed of light. Cinematically, this idea evokes wonder and subtle melancholy. The universe is both observable and untouchable, familiar and alien, its truths arriving on cosmic delay. The dual nature of light, wave and particle, adds layers of complexity to our understanding. As a wave, it spreads and interferes, creating patterns that reveal the structure of space and matter. As a particle, it carries energy in discrete packets, capable of knocking electrons from atoms and sculpting the chemistry of the cosmos. This duality is counterintuitive, almost magical, and highlights the strangeness of the universe at its most fundamental level. In cinematic storytelling, we can visualize this with rippling waves of energy cascading through space, punctuated by bursts of individual photons, each carrying the weight of information across time and distance. Understanding light is not merely an academic exercise. It is essential to understanding motion itself. Because nothing with mass can exceed light's velocity, every dream of faster-than-light travel must confront this immutable limit. The universe is structured in such a way that light defines causality, shaping the sequence of events and determining what can influence what. This realization transforms light from a passive phenomenon into the ultimate arbiter of possibility, a guiding force that both illuminates and confines. Throughout history, humans have sought to harness and understand light. From early experiments with lenses and prisms to the most sophisticated telescopes, we have used light to extend our senses across vast distances. Observatories capture photons that have journeyed for eons, revealing hidden galaxies and cosmic collisions. Each discovery reinforces the duality of light as both liberator and boundary. It allows us to see farther and understand more, yet it also reminds us of the ultimate speed limit we cannot breach. The interplay between light and perspective creates cinematic opportunities for awe and wonder. Imagine spacecraft hurtling through star fields, starlight streaming past them, illuminating every curve and shadow. Imagine observing a supernova from millions of light years away, knowing the explosion occurred long before life even existed on Earth. These visualizations evoke both curiosity and humility, emphasizing our tiny place in a vast, dynamic universe governed by rules that do not bend to desire or imagination. Light also shapes time. As we approach higher velocities, relativity dictates that time itself slows relative to an outside observer, a phenomenon intrinsically linked to the behavior of light. In cinematic terms, we can visualize clocks stretching, stars blurring into streaks, and entire civilizations moving at different temporal rhythms depending on their speed. Light is not just a cosmic speed limit. It is a sculptor of reality, dictating how motion, energy, and causality unfold throughout the universe. The more we study light, the more it seems to carry secrets beyond our immediate understanding. Quantum phenomena, like entanglement and superposition, hint that light and information may be connected in ways that defy classical logic. Cinematically, these concepts are represented by interwoven beams of energy, connecting distant points across space in an almost mystical dance. This evokes a profound sense of mystery. The universe is vast, comprehensible yet unfathomable, and light is the thread that binds it all together. As we contemplate light's role in the cosmos, we begin to understand why reaching it or surpassing it is such an insurmountable challenge. Light is at once the medium through which we perceive the universe and the barrier that defines the limits of motion. Every attempt to approach its speed brings us face to face with fundamental truths about mass, energy, and the structure of reality itself. It is both guide and guard, offering illumination while enforcing boundaries. Einstein's insight was not simply a discovery. It was a revolution that reshaped our understanding of the very fabric of reality. In the early 20th century, the prevailing belief, rooted in Newtonian mechanics, imagined a universe where space and time were fixed, and speed was a matter of engineering, limited only by human ingenuity. Objects could theoretically move infinitely fast, and the cosmos was an immutable stage on which events unfolded. Then came Einstein with his radical proposal that space and time were not separate, but intertwined into a four-dimensional continuum called spacetime, and that the speed of light was a universal constant, unyielding and absolute. The theory of relativity shattered old assumptions. It revealed that as objects move faster, time itself begins to stretch, distances contract, and mass increases. In cinematic terms, we imagine a spacecraft accelerating through the stars. As it approaches light speed, the surrounding universe distorts, stars elongate into streaks, clocks tick unevenly, and reality itself seems to bend. The contrast is striking: Newton's predictable universe replaced by a dynamic, almost surreal cosmos, where motion and time are inseparable. This is not abstract math. It is the structure of reality itself, and its implications are profound. Einstein's equations also expose the futility of surpassing light speed. As velocity increases, the energy required to accelerate grows exponentially. The faster you go, the heavier you become in the eyes of the universe, until reaching light speed would demand infinite energy. An impossible feat. Cinematic visuals could depict a vessel straining under invisible forces, its mass swelling with each fraction of acceleration, a tangible illustration of a universe that refuses to be conquered. The audience feels both awe at the elegance of these laws and dread at the inevitability of their consequences. Relativity also introduced the concept of simultaneity's relativity. Events that appear simultaneous from one perspective may unfold at different times for another observer moving at high speed. Imagine two astronauts, one on Earth and one on a near-light-speed journey. What seems instantaneous for one may span years for the other. This duality challenges human intuition and reshapes storytelling possibilities, allowing cinematic narratives to explore both the personal and cosmic scale of experience. The emotional resonance is immense. Love, loss, and memory all become elastic in a relativistic universe. Through Einstein's lens, we also confront the intimate connection between energy and mass, captured in the iconic equation E=mc². A tiny amount of mass contains an astronomical amount of energy, hinting at both the universe's power and the constraints it imposes. Visualized cinematically, we might see a fragment of matter releasing a burst of light and energy so immense it could propel a spacecraft. Yet still, the laws remain unbroken, the speed of light unattainable. The tension between human imagination and cosmic rule is palpable, an elegant dance between ambition and inevitability. Einstein's work also transformed our understanding of gravity. Rather than a mysterious force acting at a distance, gravity is the curvature of spacetime itself, bending light, shaping orbits, and dictating motion across the cosmos. Black holes, bending starlight into eerie arcs, are a dramatic manifestation of these principles, cinematic proof of a universe both beautiful and uncompromising. Here, contrast framing deepens emotional impact. The sublime beauty of warped light against the terrifying power of gravity, hope against fear, curiosity against the unknown. The revolutionary nature of Einstein's insight is also emotional and philosophical. Humanity is no longer the master of an indifferent universe. We are participants in a cosmic tapestry that obeys rules far more intricate than we ever imagined. Our desires for speed and conquest collide with the immutable laws of nature, yet these same laws open the door to wonders previously inconceivable. Cinematically, we can juxtapose human figures against bending starlight or spacecraft navigating warped space, emphasizing the grandeur and humility intrinsic to this understanding. Moreover, relativity changes the meaning of motion itself. Speed is no longer absolute. It is relative to the observer. One astronaut's leisurely cruise past a star may appear lightning fast to another watching from afar. This relativity challenges everyday intuition, forcing us to rethink fundamental notions of distance, duration, and the nature of experience. The audience is drawn into a cognitive tension, simultaneously grasping and questioning the fabric of reality, evoking both intellectual awe and emotional resonance. Einstein's theory is also a story of human curiosity and audacity. It demonstrates that our understanding of the universe is provisional, subject to revision, and yet capable of profound accuracy. The cinematic narrative here contrasts the elegance of equations with the lived, tactile experience of space. The stretch of light, the distortion of time, and the sheer immensity of the cosmos rendered both mathematically and viscerally. It is a fusion of intellect and imagination, a testament to human ingenuity facing the vastness of reality. Ultimately, Einstein's revolutionary insight reframes the dream of light-speed travel. It is not merely an engineering challenge. It is a confrontation with the deepest structure of spacetime itself. The contrast between human aspiration and universal law, between fantasy and reality, defines the cinematic tension of this journey. As we marvel at the universe's elegance and grapple with its unyielding constraints, we begin to understand that the dream of outrunning light is not a failure of creativity. It is an encounter with the sublime order of existence, where beauty, logic, and impossibility coexist in a breathtaking cosmic tableau. As an object accelerates toward the speed of light, the universe responds in ways that defy common intuition. Mass, the very substance of matter, begins to behave strangely, growing heavier with every fraction of velocity gained. What once seemed like a light, maneuverable spacecraft now becomes an object of immense resistance, as if the universe itself were applying brakes. Energy demands skyrocket, not linearly, but exponentially. To move faster is to pour more and more energy into the vessel, a process that quickly approaches infinity as light speed nears. Cinematically, we can visualize a ship straining against invisible forces, engines blazing, yet unable to achieve the impossible, each meter forward a monumental struggle against nature itself. This relationship between speed, mass, and energy is encoded in the very laws of physics. As velocity increases, time slows relative to a stationary observer, distances contract along the axis of motion, and mass grows heavier in a feedback loop that punishes acceleration. For every step closer to light speed, the energy required multiplies, creating a wall that no human or machine can surmount. The audience feels both awe and frustration, as the elegant mathematics of relativity transforms into a visceral, almost tangible barrier. It is not merely a technical limitation, it is a cosmic decree. The energy problem extends beyond sheer propulsion. Even if we could harness energy on an unimaginable scale, the structural integrity of any material faces extreme challenges. At near-light speeds, interstellar particles impact with devastating force, radiation intensifies, and the spacecraft itself risks disintegration. Cinematic sequences could depict a vessel slicing through cosmic debris, photons colliding with metallic hulls, the relentless void both beautiful and lethal. This contrast between ambition and consequence heightens tension, illustrating that moving faster is not just a matter of power. It is a battle with the universe's fundamental rules. To illustrate, imagine a spacecraft attempting to reach 99% of light speed. The energy needed is comparable to the output of entire cities compressed into a single, continuous thrust. As velocity climbs, mass increases according to Einstein's equations, demanding even more energy, in a feedback loop that escalates toward infinity. The visual metaphor is striking. A vessel glowing with energy, engines straining, yet progress slowing against the invisible wall of physics. The audience experiences the paradox. More effort produces less effect, highlighting the elegance and cruelty of relativistic mechanics. Beyond engineering, this section explores the philosophical implications of the energy barrier. Humanity dreams of speed as liberation, yet the universe imposes limits that are inescapable. The more we strive to surpass them, the more evident their absolute nature becomes. Cinematically, this can be depicted through a juxtaposition of human determination with cosmic immutability. Astronauts pushing forward, eyes burning with resolve, while stars streak past, indifferent to desire or effort. The tension between hope and inevitability creates emotional resonance, reinforcing the narrative that some boundaries are not meant to be broken. Energy is not just a hurdle, it is a storyteller in its own right. The cost of motion at relativistic speeds illuminates the scale of ambition and the magnitude of the universe. It forces a reckoning with limits, a confrontation with laws that are impartial, exacting, and unyielding. This contrast between human imagination and universal reality becomes cinematic poetry, a visual and intellectual meditation on the struggle between aspiration and constraint. The viewer senses the enormity of the challenge, the stakes of cosmic ambition, and the brilliance of the laws that govern existence. In parallel, mass increase introduces practical consequences for navigation and momentum. A ship approaching light speed cannot simply coast or drift. Every maneuver requires recalculation, immense force, and careful consideration of relativistic effects. Time dilation, length contraction, and gravitational influences all compound, transforming the journey into a multidimensional problem that tests both intellect and endurance. Cinematically, this can be represented by instruments oscillating wildly, star fields warping unpredictably, and the crew confronting the incomprehensible demands of near-light travel. The audience is drawn into the tension, feeling the magnitude of forces that are otherwise invisible but profoundly consequential. This relentless relationship between speed, mass, and energy ultimately serves as a cosmic narrative device. It illustrates the universe's impartiality and the poetic justice of its rules. Ambition is matched by challenge, desire by impossibility. We see both the beauty and severity of nature, and the cinematic contrast between human creativity and the universe's immutability deepens engagement. Every acceleration, every effort, every calculation emphasizes the interplay of wonder and futility, awe and frustration, painting a vivid tableau of the ultimate speed barrier. The energy problem is also a story of scale. While we can manipulate matter and energy on Earth, the cosmos operates on scales that dwarf human comprehension. To approach light speed, one must think in terms of stellar outputs, cosmic energies, and forces that strain the imagination. This juxtaposition, human ambition against cosmic magnitude, creates tension and engagement, framing the narrative around the ultimate test of ingenuity and endurance. Cinematic storytelling here emphasizes contrasts. Fragile human vessels against infinite energy, fleeting human lives against the vastness of space, aspiration against unyielding law. In the end, the exponential growth of energy required to reach light speed illustrates a fundamental truth. Some limits are absolute. The universe, in its elegance and precision, permits us to dream, to build, and to explore, but it guards its ultimate boundaries fiercely. Through the interplay of mass, energy, and velocity, we are shown both the beauty and the cruelty of cosmic law. The cinematic journey is one of awe, tension, and revelation. The closer we attempt to approach light speed, the more the universe reminds us that certain heights cannot be scaled, certain velocities cannot be attained, and certain dreams, though magnificent, must remain aspirational. The speed of light is more than just a number, it is a universal boundary, a cosmic speed limit that defines the framework of reality. Nothing with mass can surpass it, and nothing can even reach it without facing insurmountable consequences. Imagine a spacecraft hurtling through the void, engines blazing, approaching the ultimate velocity. As it draws closer to light speed, every aspect of motion begins to warp. Time stretches, distances contract, and mass increases. The universe, in its elegant impartiality, enforces this limit with unwavering rigor, turning human ambition into a cinematic struggle against immutable laws. This cosmic speed limit is woven into the very fabric of spacetime. Light itself becomes both a guide and a boundary, dictating how cause and effect unfold across the universe. Nothing can transmit information faster than light, meaning that every action, every signal, every decision is constrained by this ultimate speed. Cinematic imagery evokes photons streaming across galaxies, racing to deliver the first whispers of distant events, while all matter is confined to follow the same unyielding rules. The contrast is compelling. Light moves freely, untouchable, while even the most advanced spacecraft remain shackled by nature's decree. The implications of this speed limit are profound. It shapes not only motion, but also our perception of reality. As a spacecraft approaches light speed, the universe around it distorts dramatically. Stars stretch into brilliant streaks, time slows relative to observers left behind, and the vacuum of space becomes an unforgiving arena of relativistic phenomena. Every attempt to reach or exceed light speed magnifies these effects, creating a surreal tableau where the laws of physics are both visible and unbreakable. Cinematically, this tension can be rendered in breathtaking sequences, blending awe-inspiring visuals with a growing sense of futility. Even hypothetical propulsion technologies, from nuclear drives to antimatter engines, confront the same boundary. No matter how advanced, they are subject to the relentless mathematics of relativity. Energy demands climb exponentially, mass grows toward infinity, and the vessel asymptotically approaches the speed of light without ever attaining it. The universe enforces its speed limit not through malice, but through the precise, impartial logic of its physical laws. The audience senses both wonder and frustration, witnessing humanity's dreams collide with cosmic reality. The cosmic speed limit also governs communication. Signals between stars, or even within our own solar system, are bound by light speed. This affects navigation, information exchange, and the very notion of simultaneity. Messages that seem instantaneous locally may take years to traverse the void, creating delays that would confound even the most sophisticated interstellar missions. Cinematic storytelling can emphasize this tension through visual contrasts. A spacecraft moving at near-light speed, racing against a signal that will never be overtaken, highlighting the immutable nature of cosmic law. Furthermore, the speed limit reveals a deeper philosophical tension. Humanity longs for instantaneous travel, for the ability to reach distant stars and witness distant events in real time. Yet the universe imposes a boundary that is absolute, forcing us to reconcile aspiration with limitation. Cinematically, we can juxtapose ambitious spacecraft against the unyielding flow of starlight, evoking both admiration and humility. This tension, the push against an unbreakable limit, becomes a central narrative thread, highlighting the interplay between human curiosity and cosmic law. The consequences of approaching light speed extend beyond motion into the very experience of time. Time dilation means that travelers would age more slowly relative to those left behind. While this offers tantalizing possibilities for near-light speed journeys, it also underscores the impossibility of outrunning light itself. Every approach to this ultimate velocity amplifies relativistic effects, emphasizing the separation between human perception and universal reality. The audience feels the emotional weight of these phenomena, hope and excitement tempered by the unavoidable truths of physics. The cosmic speed limit also manifests in the hazards of near-light travel. At such velocities, even tiny particles of interstellar dust can strike with devastating energy, radiation intensifies, and navigation becomes perilous. Cinematically, a spacecraft might appear to slice through a storm of high-energy particles, glowing and trembling under invisible forces, illustrating that speed is not just a matter of propulsion, but a confrontation with the universe's raw power. The contrast between human ingenuity and the unforgiving cosmos heightens suspense and emotional engagement. Ultimately, the speed of light is both a boundary and a guide. It defines what is possible, shapes our perception of reality, and governs the rules of causality. Every attempt to approach it illuminates the universe's elegance and impartiality, creating tension between ambition and limitation. The cinematic narrative is rich with contrasts. Motion versus stillness, desire versus reality, human audacity versus cosmic law. Through these juxtapositions, the audience experiences both awe and apprehension, understanding that some frontiers, no matter how dazzling, remain unconquerable. The speed of light is a reminder that the universe operates on principles far grander than our desires. It challenges our imagination, tests our creativity, and imposes a limit that is both a barrier and a source of wonder. Cinematic storytelling can render this with stunning visuals. Starfields stretching endlessly, photons racing past, and spacecraft straining against invisible forces. The audience is drawn into a tension that is both intellectual and emotional, feeling the allure of speed while grasping the impossibility of surpassing light itself. In this contrast lies the essence of the cosmic journey, the thrill of ambition framed by the beauty and inevitability of universal law. As a spacecraft approaches the speed of light, time itself begins to betray intuition, stretching and twisting in ways that are both astonishing and unsettling. This phenomenon, known as time dilation, transforms the very experience of reality for those traveling at near-light speeds. For the astronauts aboard, minutes may pass as usual, but for observers back on Earth, years or even decades might elapse. Cinematically, this creates a striking contrast. Intimate, human moments unfolding inside a spacecraft while the vast cosmos outside marches relentlessly forward, indifferent to the lives contained within. The audience is drawn into both wonder and tension, feeling the profound emotional and physical consequences of relativistic travel. Time dilation is not merely a curiosity. It is an unavoidable consequence of Einstein's relativity. As velocity increases, the flow of time slows relative to stationary observers, bending the familiar rhythm of life. A clock aboard the vessel ticks ever more slowly, each second stretching into something almost tangible, while light from distant stars continues its ceaseless journey across space. Cinematic storytelling can dramatize this effect with visuals of elongated star streaks, warped instruments, and the subtle dissonance of human perception against universal time. The experience becomes surreal, a dreamlike interplay of motion, duration, and scale. The implications are both practical and philosophical. Astronauts traveling near light speed would return to a world drastically changed, where loved ones have aged decades or centuries in what felt like weeks or months to them. The emotional weight is immense. Hope, loss, and the human longing for connection are stretched across relativistic distances, highlighting the cost of venturing toward the ultimate speed. Cinematically, we can juxtapose scenes of youthful explorers returning to empty worlds or civilizations transformed beyond recognition, evoking awe, melancholy, and profound empathy. Time dilation also redefines cause and effect. Events that appear simultaneous from one perspective may be staggered across years for another. A signal sent from a near-light-speed spacecraft could arrive centuries later on Earth, and by the time it is received, the context of its origin may be entirely altered. This phenomenon challenges human notions of continuity, stability, and prediction, creating narrative tension that is both intellectual and emotional. The audience senses the fragility of temporal perception, caught between the linearity of human life and the elasticity of relativistic time. The effect of time dilation is dramatically magnified as speed increases. At 90% of light speed, time slows perceptibly, but at 99%, the difference becomes extreme. A journey that seems brief aboard a spacecraft could span millennia externally. Cinematic representations might show star fields compressing and stretching, instruments distorting, and crew members witnessing cosmic events in slow motion, all while Earth ages far beyond recognition. This visual and conceptual tension emphasizes the profound consequences of chasing near-light-speed travel. Beyond individual experience, time dilation reshapes communication and coordination. Interstellar exploration becomes an intricate dance of delayed signals and asynchronous events. A message sent to Earth from a near-light-speed vessel might arrive long after the circumstances it describes have changed, creating practical and philosophical dilemmas. Cinematic storytelling can render this tension through split-screen narratives, one side showing real-time events aboard the spacecraft, the other portraying the passage of decades on Earth, highlighting the emotional and strategic challenges posed by relativistic travel. Time dilation also poses existential questions. What does it mean to live a life so detached from the universe you leave behind? Astronauts may witness human progress, decline, or extinction from a skewed temporal perspective. Cinematic imagery can emphasize isolation, portraying solitary figures moving through star-streaked corridors, aware that every second aboard stretches across eons elsewhere. The audience is confronted with a deep mixture of awe, fear, and curiosity, experiencing both the thrill of exploration and the weight of temporal separation. Moreover, time dilation transforms our perception of motion itself. Near-light-speed travel compresses and stretches space in tandem with time, creating scenarios where cause and effect intertwine in unexpected ways. Stars streak past, light bends, and distances warp, producing a universe that feels both intimate and alien. Cinematic techniques can visualize these distortions with striking visual metaphors. Corridors elongating, celestial bodies stretching, and instruments reacting unpredictably to relativistic phenomena. The audience experiences the disorienting and awe-inspiring nature of motion at the edge of physical law. Relativity also allows us to consider extraordinary possibilities. Travelers could, in a sense, leap forward into the future, experiencing minimal subjective time while centuries pass externally. Yet this comes with profound ethical and emotional consequences. The knowledge that loved ones, civilizations, and even entire ecosystems have evolved or vanished, while you've remained almost unchanged, creates a tension between achievement and alienation. Cinematic storytelling can explore this through personal vignettes, emphasizing human emotion against the vast, indifferent canvas of cosmic time. Ultimately, time dilation illustrates the paradoxical nature of near-light-speed travel. It offers a tantalizing glimpse of human transcendence while simultaneously confronting explorers with isolation, loss, and altered perception. The contrast between intimate, human experience and the relentless march of cosmic time heightens engagement and emotional resonance. Cinematic sequences juxtaposing the personal and the cosmic allow the audience to viscerally feel the consequences of relativistic speeds, bridging intellectual understanding with empathetic experience. Through this lens, the dream of traveling near light speed is revealed not only as a technical challenge but as a profound exploration of time, perspective, and the human spirit. The quest to reach near-light speeds is not just limited by the laws of relativity. It is fundamentally constrained by the staggering energy required to propel any object toward this ultimate velocity. Every increment of acceleration demands exponentially more power, an energy cost that quickly becomes astronomical. To push a spacecraft to even 90% of light speed, the energy needed rivals the combined output of entire nations, compressed into a single, continuous thrust. Cinematic visuals might depict colossal engines glowing with raw power, thrumming against the void. Yet no matter how immense the effort, the universe's laws ensure that progress toward light speed slows asymptotically, approaching a limit that cannot be breached. This energy problem transforms the dream of light speed travel into a battle of cosmic scale. As velocity increases, mass grows, and with it, the energy required grows even faster. It is a feedback loop of relentless intensity. More speed demands more energy, which increases mass, which demands even more energy. The audience can viscerally sense the futility through cinematic imagery. Engines straining, fuel reservoirs glowing ominously, spacecraft stretching and shimmering under invisible forces. A brilliant dance of light and power illustrating the universe's unyielding rules. Even if humanity could harness unimaginable energy sources, such as antimatter or fusion on an unprecedented scale, the challenges remain extreme. At near-light speeds, collisions with interstellar particles, even dust smaller than a grain of sand, release energies comparable to nuclear explosions. Radiation levels intensify, threatening both instruments and life. Cinematic storytelling can bring this to life with visual contrasts. Spacecraft glinting under photon bombardment, shields straining against invisible forces, and the silence of space punctuated by flashes of lethal energy. The audience is drawn into the danger and drama inherent in pursuing such velocities. Energy is also intimately tied to the fundamental limitations imposed by mass and velocity. Einstein's famous equation, E=mc², illustrates that mass and energy are interchangeable, but it also implies that accelerating an object with mass to light speed would require infinite energy. In cinematic terms, this can be portrayed through a spacecraft glowing with immense power, straining to move, its progress infinitesimal despite titanic effort. The juxtaposition of human ingenuity against the infinite demand of nature creates tension, awe, and a palpable sense of scale. The energy problem is not purely mechanical. It carries philosophical weight. Humanity's desire to move faster, to explore, and to conquer the cosmos is immense, yet it meets a ceiling imposed not by imagination but by the universe itself. Every attempt to overcome this ceiling illuminates our limits, highlighting the gap between aspiration and reality. Cinematic sequences can underscore this duality. A rocket blazing toward distant stars, only to slow as the energy required multiplies beyond reach, reinforcing the narrative that some boundaries are absolute. Interstellar travel, even at fractions of light speed, transforms energy into a multidimensional problem. Not only must propulsion be considered, but shielding, navigation, and life support systems all demand power. The closer one approaches light speed, the more extreme the conditions as relativistic effects compound. Cinematic visualization might depict star fields streaking past, spacecraft hulls glowing from radiation exposure, and instruments struggling to measure reality in a world stretched and compressed by velocity. The audience feels both the wonder and terror of confronting these energy demands firsthand. Moreover, the energy barrier frames a dramatic narrative of contrast. Human creativity and technological mastery are immense, yet the universe imposes immutable restrictions. Each breakthrough in propulsion theory, each imagined engine or exotic fuel source, encounters the same universal limit. Cinematic storytelling thrives in this tension. Ambitious spacecraft juxtaposed against an unyielding cosmos, bright lights of technology against the dark, indifferent void, human hope contrasted with cosmic law. It is a visual and conceptual metaphor for the struggle between aspiration and limitation. Energy also dictates strategic considerations. Even if a spacecraft could approach near-light speeds, the enormous energy cost would limit maneuverability, acceleration, and deceleration. Every course correction becomes a monumental task, requiring careful calculation and resource management. Cinematically, this could be depicted as a slow, deliberate motion of a vessel through a star-streaked expanse, engines glowing steadily yet incapable of the instantaneous maneuvers often imagined in science fiction. The audience is reminded of the practical consequences of theoretical ambition. The energy problem also intersects with human psychology. The knowledge that enormous effort yields diminishing returns instills both awe and frustration. Observers and potential travelers confront a paradox. The closer they approach the ultimate speed, the more unattainable it becomes. Cinematic sequences can dramatize this through tension-filled visuals. Spacecraft seemingly on the verge of breaking through a cosmic barrier, only to be held back by forces invisible but absolute, blending intellectual understanding with emotional impact. Finally, the energy problem emphasizes the profound beauty of the universe's design. It is precise, impartial, and exacting. It allows for incredible exploration and discovery, yet enforces boundaries that no ingenuity can violate. Cinematic storytelling can highlight this elegance. Starfields flowing past, spacecraft straining yet contained, light streaming as both guide and limit. The audience experiences a sense of awe mixed with humility, understanding that near-light speed travel is not just a technical challenge, but a confrontation with the universe's fundamental principles. It is a story of ambition, consequence, and the sublime order of existence. As we contemplate near-light-speed travel, another profound barrier emerges. The universe itself is a perilous environment. Space is not empty in the conventional sense. It is filled with particles, radiation, and cosmic phenomena that pose extraordinary hazards to any object moving at relativistic velocities. A tiny fragment of interstellar dust, harmless at ordinary speeds, becomes a devastating projectile when encountered near light speed. The kinetic energy of such collisions can release the force of a nuclear explosion, capable of obliterating even the most fortified spacecraft. Cinematic visuals can portray a vessel slicing through a starfield, each particle impact sparking flashes of lethal energy, emphasizing the stark contrast between human ingenuity and the indifferent dangers of the cosmos. Radiation compounds the peril. High-energy photons, cosmic rays, and charged particles bombard a spacecraft relentlessly, and their effects intensify dramatically as velocity increases. At near-light speeds, even low-density cosmic gas becomes a deadly hazard. The crew inside must contend with shields that glow and strain under invisible energy, instruments measuring impacts that are instantaneous and violent, and the constant awareness that the universe's smallest elements can wield unimaginable force. Cinematic storytelling can heighten tension through sequences of glowing, shimmering protective fields and the eerie silence of the void, juxtaposed against the omnipresent danger. Navigational hazards also scale with speed. At sublight velocities, collisions can be avoided through careful course plotting, but near-light speeds compress distances and warp perception. Stars, asteroids, and debris appear to stretch into streaks, and reaction times for maneuvering are drastically reduced. Even a slight miscalculation can have catastrophic consequences. Cinematically, the spacecraft might glide past elongating celestial objects, instruments flickering as the crew anticipates each potential collision, creating suspense and immersing the audience in the perils of relativistic travel. The environment itself also warps under relativistic effects. As a ship accelerates, the starlight ahead appears blue-shifted, increasing in energy, while light from behind redshifts and fades. This phenomenon is not just visually striking. It has practical implications. Blue-shifted light carries enormous energy that can damage instruments and threaten life, while the red-shifted view behind emphasizes the alien nature of the journey. Cinematic techniques can dramatize these visual transformations. Stars stretching into radiant lines, light bending and intensifying, enveloping the spacecraft in a surreal, almost otherworldly glow. The audience perceives both wonder and danger simultaneously. Interstellar gas clouds, often appearing serene from a distance, become formidable obstacles at relativistic speeds. The density of particles, combined with the tremendous energy of high-velocity impacts, creates a scenario where even seemingly empty space becomes a lethal gauntlet. Cinematic sequences can depict these clouds as ethereal but threatening, with spacecraft shields shimmering under repeated bombardment, emphasizing that the universe's beauty masks immense peril. The narrative tension is heightened. Every moment of travel carries existential stakes. Radiation hazards extend beyond particles to include high-energy photons from cosmic phenomena like supernovae, quasars, and gamma-ray bursts. At light-speed adjacent velocities, exposure to these bursts can be catastrophic. Cinematically, a spacecraft might encounter a sudden flare, its hull illuminated in blinding brilliance, instruments alarmed, the crew responding to the invisible but deadly wave. The sequence underscores both the unpredictability and the omnipresence of cosmic danger, blending awe and dread. Even gravitational effects must be considered. Massive objects warp spacetime, bending light and altering trajectories. At near-light speeds, the spacecraft's path is subject to relativistic distortions, making navigation an extraordinary challenge. The audience can visualize this with cinematic depictions of stars bending and stretching, gravitational wells warping the vessel's path, and instruments displaying fluctuating vectors. This reinforces the duality of exploration and risk. The universe is both guide and gauntlet. Micrometeoroids, nearly imperceptible at ordinary speeds, become potential annihilators at relativistic velocities. The spacecraft must employ advanced shielding, which itself demands enormous energy, weight, and resources. Cinematic storytelling can emphasize the drama of invisible threats. Sensors detecting incoming particles, shields glowing as they absorb impacts, and the crew witnessing flashes of energy with each collision. The audience feels both the fragility of human endeavor and the relentless hostility of space. Finally, the combination of all these hazards, radiation, particles, gravitational distortions, and relativistic visual warping, creates a universe that is beautiful, surreal, and deadly all at once. Cinematic storytelling can juxtapose awe-inspiring vistas with imminent, invisible danger, emphasizing the tension between human aspiration and cosmic reality. Every frame can convey that while the dream of light-speed exploration captivates imagination, the environment itself is an unyielding adversary, shaping the narrative with peril, wonder, and emotional resonance. The challenges of near-light speed travel remind us that the universe is not merely a backdrop for adventure. It is an active participant, a force that tests ambition, ingenuity, and courage. Cinematic sequences blending breathtaking visuals with subtle menace highlight the duality of exploration. Humans reach ever farther, yet the cosmos enforces boundaries that demand respect, preparation, and ingenuity. In confronting these hazards, we begin to understand that light-speed dreams are entwined with the stark realities of the universe, a balance of awe, danger, and the immutable laws of physics. As we probe the concept of traveling at light speed, we confront the profound consequences of relativity, particularly the phenomenon known as length contraction. According to Einstein's theory, as an object approaches the speed of light, the distances in the direction of motion shrink dramatically from the perspective of the traveler. Imagine a spacecraft hurtling toward a distant star. From the crew's perspective, the journey appears shorter, stars draw closer, and entire light-years compress into perceptible distances. Cinematically, this effect can be illustrated by stretching and warping starfields outside the spacecraft's viewport, giving the audience a visceral sense of space itself bending under the influence of velocity. Length contraction is counterintuitive yet unavoidable. While the universe at rest remains vast and infinite to a stationary observer, the near-light-speed traveler experiences a world compressed along the axis of motion. This paradox emphasizes the relativity of measurement and perception. Cinematic storytelling can exploit this visually. Stars elongating into streaks, cosmic structures appearing flattened, and distant galaxies seemingly rushing toward the ship. These distortions create a visual metaphor for the tension between human perception and universal law, a constant reminder that the universe does not conform to intuitive expectations. The consequences of length contraction extend beyond perception. They also challenge navigation and trajectory. At relativistic velocities, distances shrink, but energy, momentum, and time dilation simultaneously complicate motion. Maneuvering a spacecraft requires precise calculations that account for contracted distances and warp timing. Cinematic sequences could depict a pilot or AI system calculating routes in real time, starfields compressing and expanding as instruments display relativistic corrections, creating tension and a sense of technological ballet in the void. The audience is immersed in the cognitive and emotional demands of near-light-speed travel. Length contraction also alters the experience of observation. Objects ahead of the spacecraft appear foreshortened, while light from behind stretches and fades. This creates a surreal, almost hallucinatory visual landscape, where perception itself is distorted. Cinematic techniques can portray this through dynamic camera effects. Corridors inside the spacecraft elongating, star patterns compressing outside, and visual cues shifting in unpredictable ways. The effect communicates the alien nature of relativistic motion, emphasizing that the universe behaves in ways profoundly different from daily human experience. Furthermore, length contraction is intrinsically linked with time dilation. As distances shrink along the path of travel, time for the traveler slows relative to those at rest. These two relativistic effects work together to create a universe that is simultaneously compressed in space and expanded in temporal experience. Cinematically, This duality can be represented by juxtaposing fast-moving instruments and controls with the slow, deliberate passage of the crew's subjective time, enhancing audience understanding of the mind-bending consequences of high-speed travel. The philosophical implications of length contraction are equally profound. It challenges our notions of space, distance, and connection. A star that seems impossibly far from Earth can appear within reach to a near-light-speed traveler. Yet the journey is marked by isolation, relativistic hazards, and temporal separation from the rest of humanity. Cinematic storytelling can highlight this tension by juxtaposing intimate human moments aboard the spacecraft with compressed vistas of a vast, indifferent universe outside. The audience experiences awe, tension, and existential reflection simultaneously. Even the simplest actions are transformed by relativistic effects. Measuring distances, plotting trajectories, or estimating arrival times requires factoring in contraction along the axis of motion. Instruments must account for the fact that space itself is not static, but dynamic relative to the observer. Cinematically, this can be visualized through interactive HUDs, star maps stretching and warping, and crew members reacting to real-time distortions, creating a sense of constant vigilance and high stakes in navigation. Length contraction also affects the perception of other spacecraft or celestial bodies moving at relativistic speeds. Collisions, encounters, or communication are all influenced by contracted distances, requiring precise calculations and adjustments. Cinematic visuals can show rival vessels appearing compressed, cosmic phenomena warped, and the relative motion between objects both mesmerizing and dangerous. The audience feels the tension of motion and the fragility of precision in a universe where distances are no longer absolute. The interplay of length contraction with energy and mass further complicates travel. As mass increases with velocity and distances contract, energy expenditure becomes critical. Every adjustment in trajectory consumes exponential amounts of energy, reinforcing the limitations imposed by relativistic physics. Cinematic storytelling can depict glowing energy conduits, engines straining, and the spacecraft almost frozen in effort despite rapid motion, emphasizing the paradox of motion at the edge of physical law. Ultimately, length contraction is a dramatic illustration of the universe's alien logic. It transforms familiar concepts of space into something malleable and relative, challenging human intuition and imagination. Cinematically, it offers a wealth of visual storytelling. Starfields stretching and compressing, instruments struggling to represent reality, and crew members navigating a world where space itself bends to the dictates of velocity. The audience is drawn into the wonder, danger, and intellectual challenge of near-light speed travel, understanding that the dream of traversing the cosmos is inseparably entwined with the profound strangeness of relativistic physics. At the edge of light-speed travel, the very concept of mass becomes a central obstacle. As velocity increases, an object's relativistic mass grows, creating an almost insurmountable barrier to further acceleration. This is not a metaphorical increase. It is a tangible, measurable effect dictated by Einstein's equations. Every fraction of acceleration toward light speed adds to the spacecraft's mass, demanding exponentially more energy to achieve additional velocity. Cinematically, this can be visualized through engines straining with brilliant intensity, structural frames glowing under stress, and the ship appearing to struggle against invisible, all-encompassing forces, emphasizing the physical reality of the universe's limits. Mass increase is a feedback loop of extreme consequences. As the spacecraft moves faster, its effective mass rises, requiring yet more energy for further acceleration. The closer it approaches the cosmic speed limit, the more rapidly energy demands escalate, approaching infinity at light speed. This is a fundamental reason why no object with mass can ever reach or exceed light speed. Cinematic storytelling can render this struggle visually. The vessel glowing under immense energy, stars rushing past in streaks, and engines working at maximum output, yet producing diminishing forward motion, creating tension and awe simultaneously. This relativistic mass increase also has profound implications for structural integrity. A spacecraft designed for ordinary velocities may crumble under relativistic forces. Even advanced materials face stress beyond comprehension as velocity climbs, necessitating shields, hull reinforcements, and energy fields capable of withstanding near-light-speed impacts. Cinematic sequences can depict shimmering protective layers absorbing particle collisions, hulls warping under strain, and instruments warning of imminent stress points, reinforcing the danger and drama of relativistic travel. The audience feels the fragility of human-made technology confronting cosmic law. The consequences extend beyond engineering into navigation and maneuverability. As mass increases, acceleration becomes harder to achieve, and any course adjustments demand careful calculation and enormous energy expenditure. Cinematic visuals can show the ship slowly responding to control inputs, starfields stretching and warping, and instruments glowing as they compensate for relativistic inertia, illustrating that even the smallest movement becomes a monumental task near light speed. This heightens tension and immerses the audience in the scale of the challenge. Mass increase also affects collision hazards. At near-light speeds, interstellar particles and dust carry energy sufficient to pierce hulls, destroy instruments, or even disintegrate sections of the spacecraft. Every collision is amplified by relativistic mass, transforming the seemingly empty void into a gauntlet of invisible threats. Cinematic storytelling can depict these impacts with flashes of energy, rippling shield effects, and crew reactions that convey both awe and fear, highlighting the lethal combination of high speed and mass. The interplay between mass, energy, and velocity underscores a fundamental paradox of near-light speed travel. To accelerate, energy is required, but as velocity rises, so does mass, which in turn demands even more energy. This exponential relationship is not merely theoretical. It is a cosmic law. Cinematically, this can be portrayed by a vessel glowing ever brighter, engines roaring yet making imperceptible progress, a visual metaphor for human ambition confronting immutable reality. The audience senses both the grandeur and futility of the endeavor. Mass increase also affects the perception of momentum. The spacecraft's inertia grows with velocity, making sudden maneuvers impossible and magnifying the consequences of any collision. Cinematic visuals could depict the vessel gliding through star-streaked corridors, instruments warning of minute misalignments, and the crew calculating each movement with painstaking precision, emphasizing that relativistic travel is as much a mental and strategic challenge as a technological one. The tension is both intellectual and visceral. This phenomenon has philosophical implications as well. Humanity's desire to transcend limits clashes with physical reality, teaching lessons in humility and respect for cosmic law. Cinematic sequences can juxtapose the tiny, struggling ship against an endless, streaking universe, illustrating that no matter the ingenuity or ambition, some barriers are intrinsic to existence itself. The audience experiences awe, tension, and reflection simultaneously, understanding that near-light speed travel is as much about confronting limits as it is about exploring space. Even the smallest additions of energy near light speed result in negligible increases in velocity due to mass growth. This creates a visual and conceptual paradox. The faster you go, the harder it becomes to go faster. Cinematically, this can be represented by engines blazing with ever-increasing intensity, yet the ship's progress appearing almost imperceptible, starfields rushing past in elongated streaks, reinforcing both the dramatic and scientific aspects of relativistic constraints. The audience is drawn into the tension between effort and result, ambition and impossibility. Ultimately, the increase of mass at relativistic speeds crystallizes why the dream of reaching light speed remains unattainable for objects with mass. It is a clear, measurable, and unavoidable consequence of the universe's design. Cinematic storytelling can emphasize this with contrasting visuals. The brilliance and energy of human engineering against the unwavering rigidity of physical law, the intimate struggle of a crew against cosmic immensity, and the awe-inspiring scale of space that respects no ambition. Mass increase is both a technical and narrative device, illustrating the beauty, challenge, and inevitability of the universe's ultimate speed barrier. The dream of reaching light speed is further complicated by a subtle but profound relativistic effect, the distortion of time and space around the spacecraft. As velocity approaches the cosmic limit, the surrounding universe begins to warp in ways that defy intuition. Light from stars ahead compresses into increasingly narrow, intense beams, creating a visual effect known as the relativistic headlight phenomenon. Stars behind the spacecraft fade into darkness, their light stretched and red-shifted beyond perception. Cinematically, this can be rendered as a surreal tunnel of intense light and shadow, with streaks of stars elongating and bending as if reality itself were being pulled taut. The audience experiences both wonder and disorientation, viscerally feeling the alien nature of near-light-speed travel. This warping is not merely aesthetic, it has practical consequences. Navigating through a universe that appears compressed and distorted requires precise adjustments and near-perfect calculations. Every decision about trajectory, acceleration, or course correction must account for the altered perception of distance and direction. Cinematic sequences can depict instruments recalculating constantly, starfields stretching unnaturally, and crew members interpreting warped visuals to make life-or-death decisions. The tension between human perception and cosmic reality underscores the immense challenge of relativistic travel. Moreover, the relativistic visual effects amplify the psychological impact on travelers. The familiar, comforting view of the night sky is replaced by a tunnel of distorted light and motion, evoking awe, fear, and a sense of isolation. Human intuition fails in such environments. Depth perception, timing, and even spatial awareness become unreliable. Cinematic storytelling can portray this through subjective camera perspectives, with crew members' movements appearing out of sync with the surrounding stars, emphasizing the alien and disorienting nature of near-light-speed environments. The audience is drawn into the cognitive and emotional strain of relativistic travel. Relativistic effects also alter communication and coordination with stationary observers. Signals sent ahead or behind the spacecraft are subject to extreme time delays and frequency shifts due to Doppler effects. Messages may arrive distorted, delayed, or amplified, creating challenges for both navigation and real-time interaction. Cinematically, this can be shown with visual overlays of incoming signals stretching or compressing as they are received, instruments glowing with fluctuating data, and crew members adjusting in real time to maintain control. The audience experiences the dual challenges of technical and perceptual adaptation. The relativistic distortion of space also intensifies environmental hazards. Interstellar particles, cosmic rays, and radiation appear concentrated in the direction of travel due to Lorentz transformation, increasing the frequency and energy of impacts. Even sparse regions of space become a high-risk gauntlet. Cinematic sequences could depict particles streaking past like luminous bullets, striking protective shields, and creating visual tension as crew members react to each near miss. This combination of beauty and danger reinforces the duality inherent in near-light speed exploration. The cosmos is breathtaking, yet merciless. Length contraction, time dilation, and visual distortion all interact to create a universe that is simultaneously compressed, stretched, and skewed. The spacecraft moves through a reality that is fundamentally different from what anyone on Earth would perceive. Cinematically, this can be illustrated by overlapping visual effects. Corridors inside the ship elongating slightly, starfields outside compressing, and light bending unpredictably. The audience perceives the multidimensional strangeness of relativistic motion, feeling both awe at the beauty and anxiety at the unpredictability. These relativistic distortions also challenge traditional notions of causality and simultaneity. Events that seem immediate to the travelers may occur at vastly different times for observers elsewhere. This can create dissonance in decision-making, as actions may have delayed consequences or appear out of order relative to external observers. Cinematic storytelling can exploit this through split-screen narratives or time-lapse overlays, showing the divergence between the crew's experience and the universe outside. The audience senses the temporal and spatial complexity of relativistic travel. Furthermore, relativistic visual effects serve as a narrative tool for contrast framing. The spacecraft's confined, human-scale interior is juxtaposed against the distorted, alien exterior universe. This emphasizes both human vulnerability and cosmic grandeur. Cinematic storytelling can highlight moments of quiet reflection within the ship against the chaotic visual distortion outside, evoking a mixture of awe, tension, and introspection. The audience experiences the paradox of human intimacy amid cosmic strangeness. The cumulative effect of these distortions is both intellectual and emotional. Observers grasp the mathematical inevitability of relativistic phenomena, while travelers experience their consequences viscerally. Cinematic techniques, warped starfields, shifting light, and the interplay of interior calm against exterior chaos allow audiences to understand and feel the complexity of near-light-speed motion. The result is a powerful synthesis of science, philosophy, and visual storytelling. Ultimately, the warping of time, space, and light reinforces the central theme. Near-light-speed travel is not merely a technical challenge, but a confrontation with the fundamental structure of reality. The universe enforces its rules through elegant but uncompromising phenomena. Cinematic storytelling can leverage these distortions to illustrate the tension between human aspiration and cosmic law, creating both awe and dramatic suspense. In this interplay of perception, physics, and imagination, the audience experiences the profound strangeness, danger, and wonder of traveling at the edge of the cosmos. At near-light speeds, even the vast emptiness of space becomes a crucible of danger. Interstellar travel is often imagined as a serene, silent journey through the stars, but reality is far harsher. At relativistic velocities, every tiny particle in space transforms into a potential threat. Microscopic grains of dust, cosmic rays, and stray atoms collide with immense energy, equivalent to nuclear detonations on contact with a spacecraft. Cinematically, this can be visualized with the ship hurtling through a glittering but perilous field, shields glowing and crackling as invisible impacts strike with tremendous force, blending awe with a palpable sense of peril. The audience feels the precariousness of motion at the edge of physics, understanding that space itself can become a weapon when approached at near-light speed. Radiation intensifies the peril of high-speed travel. Ordinary cosmic radiation is already a hazard, but as a spacecraft approaches light speed, these photons and energetic particles are blue-shifted, their energy amplified to levels capable of damaging electronics or harming life. The vessel becomes a target for relentless, invisible bombardment, requiring advanced shielding and careful navigation. Cinematic storytelling can highlight this danger through shimmering energy fields around the ship, alarms flashing on control panels, and the crew reacting to unseen but deadly forces. The contrast between the beauty of streaking stars and the lethal threats they hide heightens tension and emotional engagement. Navigating at relativistic speeds introduces further complexity. Distances appear contracted due to length contraction, but the environment's hazards are simultaneously magnified by velocity. Tiny interstellar particles, normally harmless, strike with catastrophic energy, and the time available for evasive maneuvers is drastically reduced. Cinematic visuals can depict the starfield stretching into lines, sensors detecting oncoming particles, and crew members executing precise, rapid adjustments, creating a sense of constant vigilance and suspense. The audience experiences the combination of technical challenge and existential risk inherent in relativistic travel. Interstellar gas clouds and nebulae, which seem ethereal from a distance, become formidable obstacles at high velocities. Collisions with even low-density clouds can generate shockwaves, strain hull integrity, and compromise shielding. Cinematic sequences might show the ship entering a glowing haze of particles, instruments flashing warnings, and energy shields flaring to absorb impacts. The interplay of beauty and danger reinforces the narrative tension. The cosmos is simultaneously mesmerizing and lethal. Gravitational effects also become significant. Massive objects warp spacetime, altering trajectories and magnifying relativistic effects. Even a slight miscalculation near a star or black hole can send a near-light-speed vessel off course with catastrophic consequences. Cinematic storytelling can illustrate this with visual distortions. Light bending around massive bodies, stars warping, and instruments displaying fluctuating vectors. The audience perceives the interplay of cosmic scale, motion, and peril, reinforcing the high stakes of interstellar travel. Communication and coordination become extraordinarily challenging at near-light speeds. Signals are delayed, red or blue-shifted, and subject to relativistic Doppler effects. This complicates navigation, mission updates, and any attempt to interact with stationary observers. Cinematic sequences could depict the crew monitoring streams of distorted data, adjusting calculations in real time, and experiencing the psychological weight of isolation. The audience understands that near-light-speed exploration is as much about managing information and perception as it is about propulsion. Even with advanced shielding and technology, the accumulation of risk is relentless. Each particle impact, radiation burst, and gravitational anomaly represents a cumulative threat. Cinematic storytelling can build tension by layering visual effects. Repeated particle impacts, glowing hull shields, streaking stars, and tense crew reactions. The audience experiences the constant danger and unpredictability of relativistic travel, feeling both awe and apprehension at the scale and intensity of the universe's hazards. The hazards of near-light-speed travel also amplify the philosophical dimension of exploration. Humanity's desire to reach the stars confronts immutable laws and unforgiving environments. The cosmos is not an empty stage for adventure but an active, dangerous participant in the narrative. Cinematically, juxtaposing the small, fragile spacecraft against vast, streaking starfields emphasizes both human ingenuity and cosmic indifference. The audience is invited to reflect on the fragility of life, the magnitude of ambition, and the stark beauty of the universe. Ultimately, the dangers of relativistic travel underscore why light-speed exploration remains beyond reach. Every incremental increase in speed magnifies the environment's hazards, creating a world where the smallest particle can become lethal, and the universe's beauty is inseparably linked with peril. Cinematic storytelling can dramatize this duality, blending awe-inspiring visuals with suspense and danger, immersing the audience in the physical, emotional, and philosophical consequences of approaching the ultimate speed limit. The narrative tension, coupled with striking imagery, reinforces the central theme. The universe allows us to dream, but it enforces its rules with absolute rigor. This relentless interaction between velocity, environment, and hazard emphasizes the stakes of near-light-speed exploration. The cosmic frontier is mesmerizing yet deadly, offering glimpses of wonder while imposing limitations that no technology can entirely overcome. Cinematic sequences juxtaposing human ingenuity with cosmic hostility, glowing engines against invisible threats, and the crew's efforts against immutable laws create a narrative that is both visually compelling and intellectually stimulating. The audience is drawn into the drama of ambition confronted by the raw power of the universe, feeling the thrill, awe, and tension of a journey that tests the limits of physics and imagination. Near-light speed travel is not only a battle against particles, radiation, and relativistic distortions. It is also a confrontation with the limits of human perception and cognition. As velocity approaches the cosmic speed limit, the universe itself begins to behave in ways that are profoundly counterintuitive. Stars ahead compress into brilliant streaks, light bends and warps, and distances that once felt familiar shrink along the axis of motion. The human brain, evolved for a world of moderate velocities and predictable physics, struggles to interpret this new reality. Cinematically, this can be visualized by showing crew members navigating a ship whose instruments display distorted data, starfields stretching like molten glass, and corridors subtly shifting, creating a sense of disorientation and wonder. The audience is drawn into both the awe and the cognitive challenge of near-light-speed motion. Our perception of motion and time becomes increasingly unreliable at relativistic speeds. Length contraction, time dilation, and the relativistic Doppler effect all interact, creating an environment where cause and effect appear skewed. Events that seem simultaneous within the spacecraft may be separated by years for outside observers. Cinematic storytelling can exploit this tension through visual overlays, showing simultaneous occurrences on the ship and back on Earth, emphasizing the paradoxical nature of time and motion at the edge of physics. The audience feels the dissonance between intuition and reality, heightening both engagement and conceptual understanding. Visual perception is particularly affected by relativistic effects. The headlight phenomenon concentrates light from ahead into a narrow, intense beam, while light from behind fades into near darkness. Colors shift dramatically due to Doppler effects, with blue shifting intensifying incoming radiation and red shifting stretching outgoing light beyond visibility. Cinematic techniques can portray this with glowing streaks of compressed light ahead, fading starfields behind, and a shifting color palette that underscores the alien and beautiful nature of relativistic travel. The audience experiences the physical reality of motion at the ultimate speed limit, simultaneously awed and unsettled. These perceptual challenges are compounded by the psychological strain of isolation. At near-light speeds, communication with Earth is delayed, distorted, or potentially impossible in real time. The crew experiences profound temporal separation, watching centuries pass externally while their subjective time moves slowly. Cinematic storytelling can highlight this tension with scenes of crew members receiving outdated messages, empty corridors echoing, and contemplative moments as they confront the alien pace of the universe. This juxtaposition of intimate human experience against vast, indifferent cosmic time adds emotional depth and narrative tension. Navigating a relativistically warped universe also requires unprecedented precision. Even tiny miscalculations can have catastrophic consequences due to contracted distances, magnified hazards, and high-velocity collisions. Instruments must continuously adjust for length contraction, time dilation, and relativistic momentum. Cinematic visuals can show control panels glowing with dynamic calculations, starfields warping in real time, and crew members reacting swiftly to subtle changes. This conveys both the intellectual rigor and emotional stakes of near-light speed exploration, immersing the audience in the extreme challenges of relativistic navigation. The combination of environmental hazards and perceptual distortions also amplifies suspense. Interstellar particles, cosmic rays, and radiation bombard the spacecraft at energies that would be harmless at low speeds but catastrophic at near-light velocities. Cinematic sequences can depict particles streaking past like bullets, shields sparking as they absorb impacts, and the crew reacting to invisible threats, blending beauty, danger, and tension. The audience perceives both the technical complexity and the existential stakes of high-speed travel. Relativistic effects also highlight the paradox of human ambition. Travelers may cover immense cosmic distances in subjective time while centuries pass externally, creating profound emotional and ethical dilemmas. Cinematic storytelling can contrast scenes of youthful, determined explorers with glimpses of aged civilizations, abandoned colonies, or evolved societies awaiting the return of interstellar voyagers. This emphasizes the philosophical tension between aspiration and consequence, awe and isolation, hope and inevitability. Even the simplest tasks, measuring distances, plotting trajectories, interpreting signals, become extraordinary challenges under relativistic conditions. Length contraction, time dilation, and Doppler effects require constant recalibration, vigilance, and intellectual adaptation. Cinematic depictions might show crew members adjusting instruments, monitoring shifting starfields, and executing delicate maneuvers, conveying the relentless cognitive demands of high-speed travel. The audience experiences the convergence of technical complexity, danger, and wonder. Ultimately, near-light speed travel confronts humanity with both the magnificence and the alien nature of the cosmos. It transforms perception, cognition, and experience, revealing a universe that behaves according to immutable laws that are beautiful, complex, and unforgiving. Cinematic storytelling can highlight the interplay of human-scale interior life against the distorted, dynamic exterior universe, immersing the audience in both the intellectual and emotional consequences of relativistic motion. Awe, tension, and contemplation coexist, emphasizing that the journey toward light speed is as much a philosophical exploration as a technological one. This confrontation with relativistic perception and cognition reinforces a central theme. The universe is a precise, impartial arbiter of motion and time. Human ambition meets immutable law, and the more we approach light speed, the more extraordinary and alien our experience becomes. Cinematic sequences, glowing, warped starfields, distorted instruments, and intimate human moments aboard the ship allow the audience to viscerally feel this tension. In this interplay of perception, physics, and narrative, the journey toward light speed becomes a story of wonder, peril, and the ultimate confrontation with reality itself. As spacecraft approach near-light speeds, even the seemingly benign vacuum of space transforms into a landscape of intense danger and energy. Every particle encountered, atoms, dust, cosmic debris, carries immense kinetic energy, capable of destroying unshielded vessels. At these velocities, a single grain of dust becomes a lethal projectile, an invisible bullet hurtling at relativistic speed. Cinematically, this can be visualized with a spacecraft barreling through a starfield, shields shimmering and absorbing invisible impacts, flashes of energy lighting the dark void with each collision, emphasizing the lethal beauty of space itself. The audience feels both awe at the cosmic scale and the peril inherent in traveling so fast. Radiation presents another formidable barrier. Cosmic rays, high-energy photons, and charged particles, normally harmless at sublight speeds, become amplified and concentrated due to relativistic effects, including the blue shifting of incoming radiation. This transforms the spacecraft into a target for invisible bombardment, requiring shielding that can withstand energies far beyond ordinary engineering capabilities. Cinematic storytelling can dramatize this threat with glowing shields, alarms flashing across the bridge, and crew members bracing against invisible forces, highlighting the tension between technological achievement and cosmic danger. Even the emptiest regions of interstellar space are fraught with hazards at relativistic velocities. Sparse gas clouds, normally invisible and innocuous, release tremendous energy upon impact. Collisions with these clouds can compromise shielding, damage critical systems, and increase radiation exposure. Cinematic sequences could depict a ship passing through a faintly glowing haze, instruments flickering as they measure particle density, and shields sparking under repeated stress, emphasizing that no corner of space is truly safe at such extreme speeds. The audience experiences the paradox of exploration. The more distant and empty the region, the greater the hidden risk. Gravitational effects introduce further complexity. Massive celestial objects warp spacetime, bending light and altering trajectories. At near-light speeds, these distortions are magnified, making navigation a delicate dance between relativistic physics and precise engineering. Cinematic visuals can show stars warping, gravitational lensing bending light around massive bodies, and the ship's instruments continuously adjusting to maintain course. The audience perceives the scale, both physical and conceptual, of relativistic navigation challenges. Communication with Earth or other spacecraft is fundamentally altered at near-light speeds. Signals experience extreme delays, Doppler shifts, and distortions, creating challenges for coordination, navigation, and mission updates. Cinematic sequences could illustrate messages stretching, compressing, and arriving out of sync, with crew members interpreting distorted data streams in real time. This emphasizes the isolation and cognitive demands of relativistic travel, heightening narrative tension and audience immersion. Collision risk is compounded by relativistic mass increase. As the spacecraft's effective mass grows with velocity, impacts with even microscopic particles release exponentially more energy. Every tiny miscalculation becomes potentially catastrophic. Cinematic storytelling can portray glowing hull shields absorbing impacts, debris streaking past, and crew members reacting to sudden threats, highlighting both the science and the human drama of near-light speed travel. The audience experiences suspense and awe simultaneously. The hazards of high-speed travel are not merely physical, they have profound psychological effects. Isolation, temporal displacement, and the constant awareness of existential risk weigh heavily on crew members. Cinematic techniques can portray long corridors bathed in shifting light, crew members observing streaked and distorted starfields, and moments of reflection or anxiety as they confront the relentless nature of relativistic hazards. The audience senses the emotional gravity of the journey, deepening engagement. Despite advanced shielding, propulsion, and navigation systems, the accumulation of relativistic hazards remains relentless. Every increase in speed magnifies particle energy, radiation intensity, and navigational complexity. Cinematic sequences can layer these effects. Stars streaking past, glowing particle impacts, alarms flashing across the bridge, and the crew maneuvering with intense focus. The audience perceives both the beauty and danger of the universe, understanding that motion at the edge of light speed is fraught with peril. Ultimately, the environmental hazards at near-light speeds illustrate a key truth. The universe is simultaneously magnificent and merciless. Every particle, photon, and gravitational anomaly becomes a potential threat, and human ingenuity is constantly tested against cosmic forces. Cinematic storytelling can juxtapose the awe-inspiring visuals of relativistic motion with the invisible dangers that loom, emphasizing the drama of human ambition confronting immutable physical laws. The audience experiences the tension, wonder, and intellectual engagement that define near-light speed exploration. The story of relativistic hazards is also a story of contrast. The exhilaration of approaching cosmic frontiers is inseparable from the omnipresent peril, the beauty of space entwined with lethal force. Cinematic sequences that blend dazzling visuals, tense crew activity, and the invisible but palpable danger of particles and radiation immerse the audience fully. This section reinforces the central theme. Humanity's desire to reach the stars must contend with the universe's unyielding rules, creating a narrative rich with scientific insight, philosophical depth, and cinematic drama. The pursuit of light-speed travel confronts a challenge that transcends engineering and physics, the inexorable limit imposed by the universe itself. As a spacecraft approaches relativistic velocities, not only do energy requirements, mass increase, and environmental hazards intensify, but fundamental cosmic principles assert themselves with absolute rigor. No matter the ingenuity of propulsion systems, the laws of nature dictate that light speed remains an unreachable threshold for any object with mass. Cinematically, this can be portrayed through a vessel straining against invisible forces, engines glowing with unimaginable intensity, yet its progress toward the cosmic speed limit imperceptible, creating a visceral sense of struggle and awe. The audience experiences the tension between human ambition and the immutable reality of the cosmos. Time dilation, a direct consequence of approaching light speed, introduces profound implications. While a traveler experiences the journey in subjective minutes or hours, decades or centuries may pass elsewhere. This disconnect between personal experience and external reality underscores the gulf between human perception and cosmic truth. Cinematic sequences can show crew members aboard a vessel observing chronometers, comparing messages or data from Earth, and realizing that what feels like days to them equates to centuries for the rest of humanity. The audience feels the emotional and philosophical weight of relativistic travel, as the human experience is stretched and compressed in ways that defy intuition. The interplay between mass increase, energy demand, and relativistic hazards creates an insurmountable feedback loop. Every attempt to accelerate closer to light speed magnifies mass, requiring more energy, which further amplifies the difficulty of propulsion. Even the most advanced theoretical engines, antimatter, fusion, or hypothetical exotic drives cannot circumvent this barrier. Cinematic storytelling can render this struggle visually. Engines straining, conduits glowing under stress, instruments registering immense energy flows, and the ship moving forward almost imperceptibly despite colossal effort. The audience is drawn into the drama of ambition constrained by universal law. Relativistic navigation further complicates the picture. At near-light speeds, even minuscule errors in trajectory can result in catastrophic consequences due to contracted distances and amplified hazards. Collisions with interstellar particles, gas clouds, or radiation bursts become exponentially more dangerous as velocity increases. Cinematic visuals can show instruments recalculating trajectories in real time, glowing particle streams streaking past, and crew members reacting with precision and urgency. The tension between progress and peril is palpable, emphasizing that near-light speed travel is both an intellectual and existential challenge. Communication breakdown adds another layer of limitation. Messages to and from Earth experience extreme delays, Doppler shifts, and distortions, making real-time interaction virtually impossible. This isolation compounds the psychological strain on travelers, reinforcing the distance, both physical and temporal, between humanity and its explorers. Cinematically, this can be represented through delayed signals displayed on glowing consoles, crew members reading messages centuries old, and visual overlays showing the passage of time outside the vessel. The audience is immersed in the human consequences of relativistic separation, heightening emotional engagement. The cumulative effect of these barriers is the ultimate impossibility of reaching light speed. It is not a failure of technology, courage, or imagination. It is the natural consequence of the universe's design. Cinematic storytelling can highlight this through contrasts. The brilliance and power of human-engineered spacecraft against the unyielding, dark expanse of space. The meticulous calculations and heroic effort of the crew versus the unbreakable laws of physics. The intimate human scale of the vessel against the cosmic immensity it traverses. This contrast reinforces the central narrative tension between aspiration and limitation. The philosophical implications are profound. Humanity's desire to transcend its limits, to explore, to accelerate into the unknown, encounters a boundary that cannot be breached. Cinematic sequences can juxtapose the intimate interior of a ship, crew members working, conversing, contemplating, with the vast, streaking exterior universe, illustrating both the scale and the inevitability of cosmic law. The audience is invited to reflect on the beauty and harshness of a universe that allows dreams while enforcing rules with precision. Even hypothetical solutions, such as warp drives, wormholes, or space-folding technology, face enormous theoretical and practical obstacles. While these concepts captivate imagination, current understanding of physics indicates that mass-bearing objects cannot attain light speed through conventional acceleration. Cinematic storytelling can weave these speculative ideas visually, showing advanced, futuristic engines glowing and pulsating, yet progress toward light speed remaining imperceptible, blending wonder with sobering scientific reality. The audience experiences both hope and limitation, a duality that heightens engagement. Ultimately, the near-light speed barrier is a testament to the elegance and consistency of the universe. It is a boundary that shapes ambition, challenges ingenuity, and imposes profound philosophical reflection. Cinematic sequences, ships glowing against streaked starfields, instruments measuring impossible energies, and crew members navigating with utmost precision, bring this barrier to life. The audience comes to understand that light speed is not merely a technical problem but a fundamental principle of reality, a cosmic boundary that defines the limits of motion and imagination. This section emphasizes the convergence of science, philosophy, and human experience. By exploring energy demands, mass increase, environmental hazards, time dilation, navigation complexity, and communication limits, the narrative conveys why light-speed travel is fundamentally unattainable. Cinematic storytelling amplifies these themes, blending visual spectacle, emotional resonance, and intellectual insight. Viewers are immersed in a universe that is both inspiring and exacting, witnessing humanity's ambition confronted by the ultimate cosmic limit. Even if we imagine a future with propulsion technology far beyond our current capabilities, the constraints of physics remain immutable. The dream of light-speed travel cannot escape the fundamental principles of the universe. As velocity increases, mass grows without bound, energy requirements escalate toward infinity, and relativistic effects distort space, time, and perception in ways that no engineering solution can fully counteract. Cinematically, this can be represented by a spacecraft glowing with intense power, engines straining as if against an invisible wall, stars stretching and warping outside, and crew members navigating instruments that flicker and pulse under extraordinary energy demands. The audience feels the tension between human ambition and the unyielding cosmic order. One of the most striking consequences of approaching light speed is the magnification of cosmic radiation. Normally harmless particles gain kinetic energy proportional to the spacecraft's velocity. Microscopic dust, hydrogen atoms, and cosmic rays transform into high-energy projectiles capable of puncturing shields or damaging vital systems. Cinematic visuals can depict the ship surrounded by invisible streaks of energy, shields flaring as impacts are absorbed, and crew members bracing as sensors detect near misses, emphasizing the deadly beauty of a universe that is simultaneously vast, serene, and lethal. The audience experiences a mix of awe and apprehension. Time dilation further complicates the picture. The faster a spacecraft moves, the slower time passes for those aboard relative to observers elsewhere. Subjective minutes can translate to decades, centuries, or millennia externally. Cinematically, this can be illustrated with split-screen storytelling. Crew members performing routine tasks within the vessel while the cosmos outside ages rapidly, stars forming and dying in compressed timelines, civilizations rising and falling unseen. This contrast evokes a sense of isolation, existential reflection, and the profound human cost of relativistic ambition. The audience understands that speed does not simply shrink distance. It reshapes the very experience of time. Mass increase and energy demands combine to create a nearly insurmountable barrier. Even with antimatter propulsion or speculative exotic drives, the closer a spacecraft approaches light speed, the more energy is required for further acceleration. The relationship is exponential, not linear. Each additional fraction of velocity demands orders of magnitude more energy. Cinematic storytelling can illustrate this visually with glowing conduits of energy, engines pulsating with intensity, and instruments indicating almost imperceptible acceleration despite immense output, dramatizing the futility and grandeur of near-light speed motion. The audience witnesses ambition constrained by unbreakable law. Relativistic navigation compounds the challenge. Length contraction compresses distances along the axis of motion, while the universe ahead is filled with radiation, dust, and gas that pose extreme hazards. Maneuvering requires calculations of incredible precision, factoring in not only velocity but also the relativistic effects on perception and collision risk. Cinematic sequences could depict starfields elongating, warning systems beeping as micrometeoroids streak past, and crew members executing precise maneuvers to thread a safe path through a high-energy gauntlet. This visual tension reinforces both intellectual engagement and emotional suspense. Communication with the outside universe becomes effectively impossible at near-light speeds. Signals are delayed, red, or blue-shifted, and distorted, creating isolation that compounds the technical and psychological challenges. Cinematic storytelling can show delayed messages arriving as distorted light or fluctuating streams of data, while the crew works to maintain situational awareness in real time, amplifying the sense of solitude and alienness. The audience experiences the profound separation that relativistic motion imposes, both physically and temporally. Environmental hazards intensify exponentially. Even a low-density region of interstellar space is dangerous because particle collisions at relativistic velocities release tremendous energy. Cosmic rays, hydrogen atoms, and stray dust all become lethal threats. Cinematic sequences can depict streaks of particles illuminating the dark void, shields absorbing invisible impacts, and crew members reacting to sensor alerts, heightening tension while visually conveying the energy and risk inherent in high-speed travel. The audience is immersed in the drama of survival in a universe that becomes hostile at high velocity. Even theoretical solutions like warp drives or wormholes face immense challenges. While they suggest the possibility of circumventing light speed limits, current physics indicates that any mass-bearing object cannot accelerate to or exceed light speed conventionally. Cinematic representation can show vessels enveloped in speculative energy fields, engines glowing with exotic energy, yet progress through space remains visually incremental, illustrating the contrast between human ingenuity and physical reality. This creates both wonder and a sobering recognition of limitation for the audience. Ultimately, the obstacles faced at near-light speeds are multifaceted. Mass increase, energy demands, relativistic hazards, time dilation, navigation complexity, and communication breakdown all converge to create an unsurpassable barrier. Cinematically, these challenges can be depicted through a combination of glowing instruments, warping starfields, shield flashes, and crew activity, emphasizing the interplay between human determination and universal law. The audience experiences a narrative that is scientifically accurate, emotionally resonant, and intellectually stimulating. This section reinforces the central thesis. Humanity may aspire to light-speed travel, but the universe enforces its laws with precision and inevitability. The cinematic depiction of ships straining, stars stretching, and cosmic hazards intensifying allows viewers to viscerally experience the tension between ambition and limitation. It conveys that light speed is not merely a technical problem. It is a fundamental boundary woven into the fabric of reality. Human imagination and determination meet the ultimate constraint, producing awe, wonder, and reflective contemplation in equal measure. The final frontier of near-light-speed travel is defined not just by physics, but by the philosophical and existential consequences of approaching a cosmic speed limit. Even if humanity could theoretically design engines capable of producing unimaginable thrust, the universe's laws remain immutable. As a spacecraft accelerates toward light speed, time dilation, length contraction, mass increase, and energy demands converge to form an insurmountable barrier. Cinematically, this can be illustrated with a vessel glowing under immense energy output, engines pulsating with intensity, and starfields outside stretching into elongated streaks that convey both motion and distortion. Crew members operate in an environment that feels simultaneously familiar and alien, giving the audience a visceral sense of the cosmic tension between human ambition and universal law. Time at near-light speeds becomes a fluid, alien concept. While travelers may experience only hours or days, decades or centuries pass externally, effectively separating them from the universe they left behind. Cinematic sequences can depict split-screen narratives. Crew members performing routine tasks while civilizations outside rise and fall, stars form and collapse, and galactic structures evolve in accelerated timelines. This juxtaposition evokes awe, existential reflection, and a sense of isolation, emphasizing the profound human consequences of relativistic travel. The audience perceives that reaching light speed is not merely a technological challenge. It reshapes human experience itself. The cumulative effects of mass increase and energy demand form a nearly infinite feedback loop. As velocity approaches the speed of light, the relativistic mass grows without bound, requiring exponentially more energy for incremental acceleration. Even advanced propulsion concepts, from antimatter engines to theoretical fusion drives, are bound by this fundamental law. Cinematically, this struggle can be portrayed with engines straining, conduits glowing with intensity, and instruments registering tremendous energy flows, yet forward progress appearing imperceptible. The audience senses both the grandeur and the futility inherent in attempting to breach a cosmic boundary. Environmental hazards compound the difficulty. Interstellar dust, cosmic rays, and radiation, normally negligible at lower velocities, become catastrophic threats. Every particle encountered carries immense kinetic energy, capable of damaging shields, instruments, or the ship itself. Cinematic visuals can depict streaking particles flashing past the hull, protective fields sparking as they absorb impacts, and crew members responding to alarms with precise urgency. The audience experiences the lethal beauty of the universe, where motion itself transforms the void into a landscape of danger. Navigating a relativistically warped universe requires unparalleled precision. Length contraction compresses distances along the axis of motion, while high-speed travel magnifies the hazards of collisions and environmental exposure. Cinematic sequences might show instruments dynamically recalculating, starfields stretching and bending, and crew members performing split-second maneuvers to avoid unseen obstacles. The tension between motion and risk reinforces both intellectual engagement and emotional immersion, as viewers witness the extraordinary demands of near-light speed navigation. Communication is similarly distorted. Signals sent to and from Earth or other stations experience extreme delays, Doppler shifts, and frequency changes, complicating coordination and leaving the crew effectively isolated. Cinematic storytelling can visualize this through fluctuating data streams, delayed message overlays, and crew members interpreting information that arrives centuries out of sync with real time. The audience feels the profound isolation and cognitive challenge inherent in relativistic exploration. The philosophical implications of near-light speed travel are equally profound. Human ambition and ingenuity confront the immutable laws of the universe, emphasizing the limits of what is possible despite technological advancement. Cinematic sequences can juxtapose the intimate interior of the spacecraft, crew members interacting, calculating, reflecting, against the vast, distorted exterior universe. This contrast highlights both human vulnerability and cosmic grandeur, evoking awe, contemplation, and tension. The audience understands that exploration at this scale is not simply about technology, but about confronting the nature of reality itself. Even speculative concepts, such as warp drives, wormholes, or space folding, are constrained by physical laws or unresolved theoretical challenges. While these ideas ignite imagination, the practical reality remains. A mass-bearing object cannot accelerate conventionally to the speed of light. Cinematic portrayals can render these hypothetical technologies visually, engines glowing, space bending subtly, but the vessel's progress through space remains gradual, emphasizing the duality of hope and limitation. The audience experiences wonder tempered by realism, blending intellectual curiosity with emotional engagement. Ultimately, near-light-speed travel embodies a narrative of contrast. It is a story of ambition against cosmic law, human ingenuity against the immutable structure of spacetime, and beauty entwined with danger. Cinematic storytelling leverages these contrasts. Engines straining against invisible limits, shields glowing as particles streak past, crew members navigating an alien landscape of motion and time to immerse the audience fully. They witness the exhilaration, the peril, and the profound reflection that defines the quest to approach light speed. This section crystallizes the central thesis. Humanity may dream of touching the speed of light, but the universe enforces its boundaries with precision. The journey illuminates the intersection of physics, philosophy, and human experience, offering both spectacle and introspection. Cinematic sequences allow viewers to feel the tension, understand the science, and reflect on the limits of ambition, reinforcing the awe, wonder, and ultimate impossibility inherent in the pursuit of light-speed travel. As we reflect on the formidable challenges of near-light-speed travel, it becomes evident that the ultimate barrier is woven into the very fabric of reality. Human ingenuity, no matter how advanced, encounters constraints imposed by the immutable laws of physics. Mass increase, energy demands, relativistic hazards, time dilation, and navigational complexities converge to create a ceiling that cannot be breached. Cinematically, this can be depicted by a spacecraft glowing with immense energy, engines pulsating, starfields streaking and warping outside, while crew members operate within a vessel whose motion seems to struggle against invisible cosmic forces. The audience experiences a tangible sense of the tension between human ambition and the uncompromising rules of the universe. The pursuit of light speed is not only a technical struggle but also a profound philosophical challenge. As velocity increases, the passage of time itself becomes alien. Seconds for travelers may correspond to decades, centuries, or millennia for the universe beyond. Cinematic sequences can juxtapose intimate interior moments aboard the ship with accelerated external timelines, showing stars forming and dying, civilizations rising and falling, and cosmic events unfolding in rapid succession. The audience gains an emotional and intellectual sense of the gulf between human perception and universal scale, emphasizing that approaching light speed reshapes experience itself. Environmental hazards exacerbate the difficulty. At relativistic velocities, even the most tenuous interstellar matter becomes a lethal threat. Microscopic dust, stray hydrogen atoms, and cosmic rays, normally harmless, acquire kinetic energy sufficient to puncture shields and damage critical systems. Cinematic visuals can depict streaks of energy flashing past the hull, shields absorbing impacts, and crew members responding to sensor alerts with precise urgency. The interplay of beauty and danger reinforces the duality of space at near-light speeds, awe-inspiring yet unforgiving. Navigational precision becomes paramount. Length contraction compresses distances along the axis of travel, while hazards such as radiation, debris, and gas clouds are magnified by velocity. Any small miscalculation can be catastrophic. Cinematic storytelling can show instruments dynamically recalculating, starfields stretching and bending, and crew members executing split-second maneuvers. This heightens suspense and conveys the extraordinary cognitive and technical demands placed on explorers navigating a universe that is simultaneously vast, beautiful, and perilous. Time dilation and communication limitations compound the challenge. Messages to and from Earth are delayed, distorted, or shifted in frequency, rendering real-time coordination nearly impossible. Cinematic techniques can depict data streams stretching and compressing, delayed signals arriving centuries out of sync, and crew members interpreting complex information under stress. The audience senses the isolation and cognitive strain imposed by relativistic travel, deepening engagement with the human and scientific dimensions of the journey. Even hypothetical propulsion breakthroughs, antimatter engines, fusion drives, or speculative warp concepts cannot circumvent fundamental physics. As velocity approaches light speed, the energy required for further acceleration grows without bound, mass increases, and relativistic effects distort space and time. Cinematic sequences can portray engines glowing with unimaginable intensity, conduits pulsating, and instruments registering immense energy flows, while the vessel's forward motion appears imperceptible. The audience experiences the paradox of extraordinary effort yielding limited progress, a metaphor for humanity's confrontation with cosmic law. The cumulative effect of these constraints is the ultimate impossibility of light-speed travel for mass-bearing objects. The universe enforces this limit not through failure or deficiency, but through the consistent, elegant application of physical law. Cinematic storytelling can dramatize this through contrasts. Human-scale spacecraft against the infinite, distorted expanse of space. Heroic efforts aboard the vessel against the invisible but absolute speed limit. Moments of quiet reflection juxtaposed with overwhelming cosmic forces. The audience absorbs both the grandeur of ambition and the reality of limitation. Philosophically, near-light-speed travel teaches profound lessons about humanity's place in the cosmos. Ambition and creativity are powerful, yet they exist within the boundaries defined by nature. Cinematic sequences can contrast the interior of the ship, filled with diligent human activity, against the alien, distorted exterior universe, reinforcing the tension between intimacy and immensity, aspiration and impossibility. The audience experiences awe, tension, and contemplation, recognizing that exploration at this scale is as much a journey of thought and reflection as it is of motion. Ultimately, the pursuit of light speed is a narrative of contrast, challenge, and revelation. It blends technical rigor, environmental hazard, philosophical inquiry, and human resilience into a compelling story. Cinematic sequences, ships straining against energy limits, streaking starfields, shields absorbing invisible impacts, crew members calculating with precision, bring these concepts to life, creating an immersive experience. The audience witnesses the intersection of ambition, science, and cosmic law, understanding that light speed is not merely a goal to be reached, but a fundamental boundary that defines the limits of motion, perception, and imagination. This section reinforces the central thesis. The universe sets absolute limits, and human ambition is most profound when measured against them. Cinematic storytelling amplifies the scientific, emotional, and philosophical dimensions, allowing viewers to feel the tension, comprehend the principles, and reflect on the grandeur and inaccessibility of near-light speed travel. Humanity may dream of reaching the speed of light, but the cosmos enforces its laws with unwavering precision, creating a narrative that is at once awe-inspiring, intellectually rigorous, and emotionally compelling. The ultimate frontier of human ambition has always been the stars. We have looked up for millennia, measuring the motions of celestial bodies, charting the heavens, and imagining what it would be like to travel among them. The concept of near-light speed travel has fascinated physicists, engineers, philosophers, and dreamers alike, promising the ability to traverse the cosmos in ways that defy ordinary experience. Yet, the deeper we examine the laws of nature, the more it becomes evident that this dream is constrained by something far greater than technology: the fundamental architecture of the universe itself. The speed of light is not merely a number. It is the ultimate cosmic boundary, a law written into the fabric of spacetime, a limit that cannot be violated by any object that possesses mass. No matter how advanced our propulsion systems, how ingenious our engineering, or how daring our ambition, the universe enforces this rule with absolute precision. Imagine a spacecraft equipped with engines fueled by antimatter, or perhaps a speculative fusion drive that channels energy at unprecedented efficiency. The ship glows like a living entity, pulsing with power, conduits coursing with energy, and every system operating at peak capacity. Outside, the starfield stretches into elongated streaks, distorted by the ship's velocity. The visual scene itself becomes almost alien. Familiar constellations morph into smeared trails, nebulae warp under relativistic effects, and light ahead is blue shifted into brilliance, while light behind fades into darkness. Cinematically, this setting embodies a tension between the intimate, human-scaled spacecraft and the immense, indifferent universe it seeks to traverse. Crew members operate within the ship, their motions precise, their expressions tense, aware that the faster they go, the more the universe itself conspires to remind them of their limits. As the spacecraft accelerates toward light speed, relativistic effects begin to dominate reality itself. Time dilation ensures that the subjective experience of the crew diverges from the timeline of the universe outside. While hours or days may pass for those aboard, decades, centuries, or even millennia may elapse elsewhere. Civilizations may rise and fall, stars may ignite and collapse, and galaxies may evolve beyond recognition. Cinematic storytelling can portray this through juxtaposed imagery. Inside the spacecraft, routine tasks and conversations unfold normally, but external visuals reveal cosmic epochs passing in accelerated sequences. The audience is confronted with the profound isolation and temporal displacement of near-light speed travel, feeling the simultaneous thrill and melancholy of human ambition against an uncaring cosmic clock. The increase in relativistic mass is perhaps the most unforgiving of the universe's barriers. As the spacecraft approaches light speed, its effective mass grows without bound, and the energy required for further acceleration skyrockets toward infinity. Even if we imagine engines fueled by antimatter or zero-point energy, the physics itself prevents motion beyond the light barrier. Cinematic representations can dramatize this through glowing energy conduits, engines straining as if against an invisible wall, alarms flickering, and the ship's movement appearing incremental despite colossal output. The audience experiences both awe and futility simultaneously, understanding that no matter the ingenuity of human design, certain limits are inescapable. Environmental hazards multiply dramatically at relativistic velocities. The vacuum of space, which appears empty and serene at conventional speeds, becomes a deadly battlefield. Tiny particles, dust grains, stray hydrogen atoms, cosmic rays, carry kinetic energy sufficient to puncture shields or obliterate unprotected systems. The universe itself becomes a projectile range where every microscopic object is a potential threat. Cinematic sequences can show the ship surrounded by streaks of glowing energy as particles collide with shields, alarms sounding with each near impact, and crew members adjusting maneuvers with split-second precision. The contrast between the quiet majesty of the cosmos and its lethal hidden dangers reinforces both suspense and wonder for the audience. Length contraction further complicates navigation. Distances along the axis of motion shrink in the spacecraft's frame of reference, but this contraction is paired with magnified collision hazards and relativistic distortions. The starfield ahead appears compressed, while sensors detect a torrent of high-energy particles approaching from all directions. Cinematic visuals can render the starfield as a molten river of light, debris, and radiation streaking past, while crew members interpret shifting readings to maintain trajectory. The audience experiences the surreal and alien nature of near-light speed motion, feeling the constant tension between progress and danger. Communication, an essential lifeline for any interstellar mission, is rendered almost meaningless at near-light speeds. Signals to and from Earth experience extreme time delays, red and blue shifting and distortion. Messages may take decades or centuries to arriving in forms that are partially unintelligible due to Doppler effects. Cinematic storytelling can depict data streams stretching and fragmenting on consoles, crew members deciphering ancient transmissions, and the psychological strain of isolation that accompanies such temporal displacement. The audience senses the profound separation of travelers from the universe they left behind, enhancing the emotional stakes of the narrative. Time dilation and relativistic separation also carry philosophical weight. The subjective experience of travelers becomes unmoored from the collective timeline of humanity. Even as explorers move at extraordinary velocities, the world they left may evolve without them. Galaxies, stars, and civilizations age while they experience only days or weeks. Cinematic sequences can interweave personal moments aboard the ship with accelerated external timelines, emphasizing both the wonder of exploration and the existential cost of relativistic trave. The audience is invited to reflect on the fragility of human perspective in a cosmos governed by absolute laws. Hypothetical propulsion methods, warp drives, wormholes, space folding, offer visions of circumventing the lightspeed barrier, yet each faces theoretical and practical hurdles that are, for now, insurmountable. Even if spacetime itself could be manipulated to create shortcuts, the engineering challenges, energy demands, and unknown consequences present enormous obstacles. Cinematic sequences can show ships enveloped in exotic energy fields, spacetime bending subtly around them, engines pulsing with strange light, yet progress through space remains slow and deliberate. This duality evokes a sense of wonder tempered by realism. Human imagination can conceive of possibilities, but nature enforces limits with precision. Environmental hazards remain constant, regardless of propulsion. Every particle encountered at near-light speeds transforms into a potential weapon. The universe is no longer a serene void, but a kinetic landscape of danger. Cosmic rays, stray atoms, and interstellar debris strike shields with energies that can rival small nuclear explosions. Cinematic portrayals can depict these impacts as streaks of light along the hull, sparks cascading across shields, and crew members adjusting controls with urgency. The audience feels both the danger and the beauty of relativistic motion, sensing that the cosmos itself is indifferent to ambition and yet visually mesmerizing. The paradox of human ambition emerges in stark relief. Explorers seek to transcend limits, to accelerate into the unknown, yet the universe enforces boundaries that cannot be breached. Cinematic storytelling can contrast the intimate, human-scaled interior of the ship with the vast, alien, distorted exterior universe. Crew members perform tasks with precision, conduct calculations that approach the limits of cognition, and face hazards invisible to the eye, all while the external cosmos stretches, warps, and unfolds in ways that defy intuition. The audience is immersed in a narrative that is both scientific and philosophical, blending intellect, emotion, and visual spectacle. Psychological and emotional pressures compound the technical and physical challenges. Isolation, temporal dislocation, and the knowledge of universal limits weigh heavily on the crew. Cinematic sequences can portray empty corridors illuminated by flickering instrument lights, crew members contemplating the infinite outside, or moments of quiet tension as they navigate through hazardous regions. The audience senses the profound emotional stakes of near-light speed travel, understanding that exploration at this scale is not only a battle with physics but also with perception, cognition, and morale. Energy demands continue to escalate exponentially. Every increment closer to light speed requires orders of magnitude more energy. Even theoretical engines capable of harnessing antimatter or vacuum energy face insurmountable practical challenges. Cinematic storytelling can emphasize this visually. Conduits glowing with power, alarms registering unprecedented energy outputs, and the engines appearing to strain under the colossal demands, while forward movement remains subtle. The audience perceives both the brilliance and futility inherent in near-light-speed propulsion. Hazards from gravitational fields also become magnified. Massive stars, black holes, and neutron stars warp spacetime, and at relativistic velocities, these distortions can dramatically alter trajectories. A slight miscalculation near a gravitational source can result in catastrophic deviation, collision, or fatal tidal forces. Cinematic sequences can depict warped light bending around massive bodies, instruments adjusting for gravitational lensing, and crew members executing complex maneuvers in real time. The audience experiences the stakes of navigating a universe that is simultaneously predictable in its laws and unforgiving in its consequences. Ultimately, near-light speed travel embodies a profound narrative of contrast. Human ambition versus immutable law, ingenuity versus cosmic scale, hope versus limitation. Cinematic storytelling leverages these contrasts. Engines glowing against invisible resistance, shields flaring under particle bombardment, starfields stretching into alien patterns, crew members calculating, navigating, and surviving, to immerse the audience fully. They witness the exhilaration, peril, and philosophical reflection that define the pursuit of light speed. This journey also underscores the philosophical implications of cosmic limits. Humanity's dreams are boundless, yet reality enforces boundaries. The universe's laws are precise, impartial, and unforgiving, yet within those limits, human ingenuity and courage shine. Cinematic sequences can juxtapose the intimate, human-scaled interior of the spacecraft with the vast, distorted exterior universe, creating moments of awe, reflection, and dramatic tension. The audience understands that exploration at this scale is as much a journey of thought, emotion, and perspective as it is of motion. Even the most imaginative speculation, warp drives, wormholes, higher-dimensional shortcuts, cannot escape fundamental physics. Light speed represents an absolute ceiling for any mass-bearing object, a principle that is as elegant as it is unforgiving. Cinematic representations can show ships enveloped in exotic energy fields, engines glowing with unearthly brilliance. Yet forward motion remains incremental, emphasizing the contrast between human aspiration and universal limitation. The audience experiences both wonder and realism, a tension that is central to the drama of relativistic travel. In conclusion, near-light speed travel is a story of physics, philosophy, and human ambition intertwined. Mass increase, energy requirements, environmental hazards, time dilation, navigational complexity, and communication breakdown collectively enforce an immutable barrier. Light speed cannot be attained. Cinematic storytelling amplifies these principles through glowing engines, warped starfields, shields flaring under invisible threats, and human figures operating at the limits of skill and cognition. The audience experiences the full spectrum of engagement: awe, suspense, intellectual stimulation, and reflective contemplation. Humanity may aspire to touch the speed of light, yet the universe enforces its laws with exacting precision. The quest to approach light speed illuminates the boundaries of physics, the nature of perception, and the limits of human ambition. Cinematic sequences allow viewers to feel the tension, see the beauty and danger of relativistic motion, and reflect on the philosophical implications of our place in the cosmos. Light speed is more than a physical limit. It is a profound narrative device, symbolizing the boundary between possibility and impossibility, ambition and reality, hope and restraint. It is a story that blends spectacle, intellect, emotion, and philosophy, leaving the audience in awe of both human potential and cosmic law.